Hey guys, Trey here, and today wanted to do another sort of little forecast discussion on the potential severe weather event today in the southern plains. Yes, it is only February 9th, but we are seeing a chance of severe weather in the southern plains. We've got a slight risk, as you can see here, including the Dallas metro area, parts of northeast Texas, into southern Oklahoma, and then a marginal area around that extending into southwest Arkansas, northwest Louisiana, and down into parts of east central Texas. So let's go ahead and dig into some things now. It's not going to be a high-end severe event, but there is definitely a chance today. So let's take a look at some products here. We'll start off with our surface analysis. So this is our surface analysis for valid. Let's go ahead and refresh. This is valid at 9:33 a.m. Central Standard Time. So you can see we have southeasterly and southerly winds advecting warm moist air into the southern plains. You can see we have dew points almost into the 60s up into the Dallas Fort Worth area. DFW actually was 59 over 59 at the time this map was taken, just a couple minutes ago as I'm recording this. But you can see we have mid 60s, mid to upper 60s dew points down here in South Texas. Those will be advected northward today as that southeasterly flow continues. Let's take a look at the overall pattern now. So here is our 500 millibar map from 12Z this morning. Pretty zonal flow across most of the CONUS. We do have a trough that is coming down out of the Pacific Northwest, moving down into, this will move down into the southern plains over the next day or two, but this is not going to be our main feature. It's too far away. We're gonna have to rely on one of these blips in the flow, one of these little short waves rotating around this trough to kick off our action today. But other than that, really not a lot of large scale synoptic scale lift for us today. And that could be an issue later on as we look at some of the models and what they're showing. And we'll take a look and see why those may not be portraying the potential event properly. So I believe it's gonna be this little shortwave that's gonna move into the southern plains this afternoon and evening, and it will help at least a little bit with the get a little bit of synoptic scale lift in there to set off thunderstorms. And if we go back here, we'll go back a little bit to our surface map. You can see we have a cold front, very pronounced wind shift here going through western Oklahoma now and into the southern Texas Panhandle. Northerly winds in the Texas Panhandle and into southwest Kansas, while we have southerly and southeasterly winds ahead of it. This is a cold front going to move off to the southeast and be a player in our severe weather today, this afternoon. Let's take a look at some products here. So we've already determined that our large scale, our synoptic scale lift is going to be pretty minimal today. So we're going to have to rely on surface boundaries. So that cold front is going to be a big player today to help offset the lack of synoptic scale lift. If we look at satellite here, you can see that cold front pretty significantly there, up extending into northwest Oklahoma into the Texas Panhandle. A little bit of cloudiness ahead of that, but there should be some clearing ahead of it this afternoon to have instability spike a little bit. As we look at our vorticity advection, or the tendency for spin in the atmosphere. Vorticity is a big quantity in meteorology that we look for. Any vorticity maxima, ahead of that usually we get rising motion because of the QG omega equation and the QG vorticity equation and whatnot. That's a little bit ahead of this presentation, a little bit higher level than this presentation. I want to keep it simple. But we look for vorticity maxima, where there's spin in the atmosphere. And we don't see that much. This is our differential vorticity advection, so the movement of vorticity. And we're not seeing any pronounced areas really. These are very small blips of little vorticity but really there's not any vorticity maxima, really strong vorticity maxima, except on the California coast, which is not going to be a player in our action, our severe weather action today. So let's look at 850 millibars. This is where we look for our low-level jet, and you can see we have a pretty strong low-level jet. We're at the kind of the southern extent of that low-level jet. There's a big surface low up off here, up off well to our northeast, and this flow is associated with that surface low. But this, you can see 50 to 60 knots all in this area, decreasing to about 40 to 45 knots here into northeast Texas. That is going to move off to the east as the afternoon progresses, but we'll still have some strong low-level winds to perhaps enhance photographs this afternoon over northeast Texas and eastern Oklahoma. Let's now take a look at, let's go ahead and take a look at instability. Let's actually look at our sounding from this morning. This is our observed sounding from Dallas-Fort Worth at 12Z this morning, so 6 a.m. Central Standard Time. So we have fairly moist low-level environment up to about 850 millibars, and it dries off considerably. This is very poor low-level lapse rates for the most part, up until about 600 millibars or so. This is a little bit of a warm nose that could be a concern later on today. As we said, we're going to get some instability to enter the area through warm advection and some destabilization from solar heating if we can get some more clearing in the clouds we saw. But it's not going to be substantial. You're not getting 70, 75 dew points into northeast Texas, southern Oklahoma. We're probably going to see 60 to 65 dew points. So whether or not this warm nose will play a factor, it's looking pretty likely. Again, we don't have any large-scale, synoptic scale trough that's going to move into our area. If that were the case, we would get cooling ahead of that trough. As the trough approaches, that cap would really erode, and we would get substantial inhibition or a substantial instability to present itself, and this would be a much bigger day. However, we don't have that big synoptic scale forcing to cool the mid-levels and promote rising motion. So this could be a problem. Some of the models were showing warm sector storms ahead of the cold front. That probably is not going to be the case looking at this Fort Worth sounding from this morning. That warm nose is going to be pretty stubborn, I feel, and we're not going to get much in the way of severe storms in the open warm sector. Now, how do you combat this? You have a strong surface boundary, aka the cold front. So I believe storms will be confined to the cold front today. So as a result, the more linear forcing will promote a messier storm mode. Storms will tend to be probably undercut pretty quickly, and any tornado potential will be negated pretty quickly. So let's look at some models here. So this, let's take a look at the HRRR model. This was the 12Z run. So if we look at our 850 millibar winds, our low-level jet matches pretty good with what we saw on the SPC mesoanalysis page. Our strong low-level jet extending into northeast Texas, but it's going to move off to the east as the day progresses. By the time the event is going to get going, still have some remnants of that low-level jet in the area, but it is mostly moved off to the east. So as the afternoon and evening progress, photographs are going to get smaller as these strong low-level winds move out of the area. Let's kind of look at our moisture advection today. So we saw with our Dallas-Fort Worth sounding, we had a 57 dew point. If we go back to our surface map, again, we have mid to upper 60s dew points down here in South Texas. We have upper 50s dew points here in Northeast Texas. Those stronger dew points, those greater dew points, going to advect into the Dallas-Fort Worth area and the Red River region this afternoon, um, and that is going to help us out and help at least somewhat erode this very strong warm nose. But we would need some large scale lift to do so completely, and that's not gonna doesn't look like it's gonna happen. So we have pretty strong moisture advection based on this HER model, and then you can see that cold front sweeping through this evening after dark. So we do get pretty strong warm advection, dew points into the mid to upper 60s into northeast Texas, southeast Oklahoma. Let's take a look at our reflectivity. So as we go along, you can see that cold frontal boundary. There's some attempt at convection along it. What the HER is doing, though, I'm a little skeptical of. It's producing these warm sector storms, these storms out in the open warm sector. I find that pretty hard to believe, since there's going to be such strong inhibition in the mid levels. We're really going to need cooling at the mid levels, and we don't have a synoptic scale trough moving in, synoptic scale lift to promote that cooling and erode that cap. So if we take a look at a sounding, this is at 0Z this evening. Yeah, you can see we really haven't eroded that inhibition in the low levels and near the surface. Lapse rates near the surface are still pretty meager at best. You can see down here our surface to 3 kilometer lapse rate on this forecast sounding is less than 6 degrees Celsius per kilometer, which is pretty bad, and our 0 to 3 kilometer cape is only about 30, which is very meager. You can see our wind profile, though, is pretty solid, pretty small photographs, but we do have substantial turning in the low levels. But can we tap into that very strong low level shear with these meager lapse rates? My guess is no. And storms, if any storms do fire in the warm sector, they will be probably just showers. And if we do get thunderstorms, they'll be pretty elevated at best. You're going to have to go along the cold front to see any surface-based instability, which is probably going to be quickly undercut. Any storm that forms along the cold front going to be undercut quickly by the cold front itself. So not too keen on this scenario actually playing out for this area based on the HER. Let's go to our most recent HER, which is 14Z, see if anything's changed. So again, we see that cold front, little convective band along that cold front. Yeah, you can see it's backed off a little bit. There's still a couple of attempts at supercells here in the open warm sector, but it's definitely backed off from what we saw in the 12Z run as far as coverage is concerned. So I think the HER becoming a little more realistic, getting that warm nose in at 700 millibars or so, and the weak lapse rates in the low levels probably starting to show itself in these HER runs. Let's go to another convection allowing model, the WRF ARW. So this is an NSSL model. Let's see what this guy shows. And you can see the band along that cold front, and really not much in the way of convection in the open warm sector, especially in the slight risk area. There's some attempts out east in the Arklatex area, but those are probably just showers at best. And yeah, not much in the way of anything chaseable, which I think is going to be the scenario based on just our overall lack of synoptic scale lift that would help erode that instability and provide cooling at the mid levels, and to really enhance that instability overall. This is the NSSL WRF model. Let's see what it shows. And yeah, not much in the way of anything. There's a couple of attempts here southeast of the Dallas-Fort Worth area by 0Z, but not much, not even much along the cold front. So there is some overnight into northern Louisiana, but as far as anything chaseable here this afternoon, I'm thinking this type of scenario is what's going to happen. Any attempts at supercells are going to be probably elevated, probably pretty weak at best. I'm thinking we'll probably just get showers in the warm sector, and any substantial convection is going to be confined to this cold front that will help offset the lack of synoptic scale lift and and help push through that cap, help parcels push through that cap. A couple more things to look at. This is the SPC SHREF. So this is the combination of significant tornado ingredients. And you can see we have some in place. This is at 0Z this evening. We have some ingredients, some decent Cape shear overlap across parts of East Texas and Northeast Texas into southern Oklahoma. But again, that is just a combo of basically Cape and shear. We actually need storms to go in this environment to uh, get things going, really going. But this just shows that we do have the parameter space in place for a decent severe weather event today. The question is, can we get surface-based storms in the warm sector? That looks pretty unlikely. Yeah, so that is pretty much it for today. If I was chasing today, which I am not, but I would target somewhere around the Dallas-Fort Worth area, uh, get ahead of that cold front in the warm sector. I think that will be the chance for the best supercells. I think the cold front storms are going to get undercut quickly. But again, it's such a marginal day, and the chance of significant storms actually going in the warm sector is pretty meager. I wanted to show one last thing, the Dallas-Fort Worth Weather Service discussion this morning. They did mention uh, the chance for landspout tornadoes in the vicinity of the advancing cold front. Considerable 0 to 1 kilometer shear in the vicinity of the boundary may promote landspouts with rapidly developing cells. If these can develop in tandem with the enhanced lapse rates a disturbance aloft would promote, a supercell could prolong this tornadic potential. So again, they saw that little trough, that little shortwave moving through, um, and they're saying that the cold frontal boundary is going to be the best place for potential landspout tornadoes. Well, let's take a look and see for ourselves. Let's look at surface vorticity and 0 to 3 kilometer Cape. 0 to 3 kilometer Cape, again, is a proxy for low-level updraft strength. And with a landspout tornado, you want that to be as high as possible, and you want lapse rates to be as steep as possible near the surface to promote the rising of those eddies near the surface, those little spinning eddies near the surface, which are manifest in this surface vorticity field. Surface vorticity, the ability for air to spin, basically. So this is our cold frontal boundary. You can see the wind shift here. Lots of vorticity along this boundary. So that is a plus. And as we move on later through the day, we do have some 0 to 3 kilometer Cape building in according to this WRAP forecast on the SPC mesoanalysis. So as that area of substantial vorticity coincides with that increased 0 to 3 kilometer Cape, we could have landspouts along the boundary. Definitely a possibility in southern Oklahoma. But we were seeing some of those soundings, those forecast soundings, not looking great. I think this may be overdone with 0 to 3 kilometer instability. We just saw those lapse rates not really improve throughout the day near the surface. So I'm thinking that's going to be an issue for landspout tornadoes. But again, this is just a model, just a guess, and the Dallas-Fort Worth office definitely thinks there's the potential for that to happen as the cold front moves through. But as far as a supercell tornado potential, I think that's pretty low. There's a 2% out for today, and a slight risk out, including the Dallas-Fort Worth area. So if you live in this slight risk area, including the DFW area, definitely keep an eye to the sky today. There could be a brief tornado somewhere if a supercell can get going along the cold front or in the warm sector. If we can get a storm going in the warm sector, the tornado potential will ramp up, but just not seeing it at this point based on our pretty significant uh, warm nose here at 700 millibars and our pretty poor lapse rates in the low levels. All right, that's all I've got. If you're chasing today, stay safe and good luck. I will be sitting this one out. I had plans this afternoon to attend to, and just don't think this setup is going to be good enough to make me cancel those plans. But definitely a chance if a supercell can get going in the warm sector for a brief tornado or two. Probably the hail threat is going to be greatest with storms, especially along the cold front, and then that'll transition to a wind threat as the line of storms kind of congeals along the front. So that's all I've got. Thanks so much for watching. Hope this helped. If you are looking for a little forecast discussion on the severe event today, we'll see you at the next video.